I don't know if Hayden has gone virtual or not, his name hadn't been on the list yet. Let's see. I think a bunch of the baseball players are doing virtual now, though. Let's go to the list. Nope, Lopkins isn't on there. He should be, yes. So our main goal today, other than Ninja Math, is gonna be to multiply and divide with these big things. So this is just one, so it would say either times or divide, and be another one of those. But before we get to that, we wanna learn how to simplify these, because I wouldn't wanna have to have a trinomial, multiply that by another trinomial, and then reduce. So we're gonna learn to simplify these, so then we can go as we do that. And that's why I call it Ninja Math, because we'll be able to out whole sections. So what we wanna look to do on something like these is factor. That's why I stress factoring all year long. So I'll look here and I'll see what will multiply to make negative 15, but add to make negative 2. Grab a white marker. So multiply to make negative 15 and add to make negative 2. So you're looking at those factors. So you could rewrite that numerator as x minus 5 times x plus 3. Okay, so we factored the top. Now on the bottom, x squared minus 9, that'll factor, and that's one of those special kind where they're both perfect squares and they got a minus sign. Remember difference of squares? So that would factor as x plus 3 times x minus 3. Remember, and I know you know, but I gotta make sure people on the video, when it's both perfect squares and a minus sign, you just square root them, 1 plus, 1 minus. So now that we got it all factored, that's when, what time is it? Ninja time! Get your ninja sword, and anything that the whole piece is the same, you get to knock that out. So we would say right here, get to knock those out. So our final answer on the top, we got an x minus 5, and on the bottom an x minus 3, and that's it. Now every year what people want to do, they get so excited about the ninja sword, they then want to slash those out. It's got to be all of it or nothing. You can't pick apart anything, and I'll say that all throughout this. Don't pick apart, all or nothing. So pretty simple. All right, let me erase that so I can use that for next period. When Christian left, I said, you better make sure and watch the video, and he said, okay. I was like, yeah, I don't see that happening. Alright, so when I'll do a couple more of those just to make sure. This one's a little bit easier. Normally when we're working through problems, I usually skip these really easy ones, but sometimes then y'all see the really easy ones and you're like, oh, I don't know how to do that. But all that's happened on this one is it's already done the factoring step for you. So you don't have to factor anything, it's ninja time. So you just take out those big hunks. So that would just be 2 over x plus 3. So we would really like that kind. They did all the hard work for us on that. Okay, one more of those, or one more before this one we'll have to factor. I've never taught one student before, but I'm trying to remind myself I'm teaching a lot because of the video. It's like I was telling Stuart, I feel sorry for Holly today. All right, so it's not factored, and we can't, there'll be students that'll try. They'll just try to start marking these out. We can't do that. It's got to be all of it or nothing. So what do we have that we could multiply and get -3, but add and get -2? It'd be the other way though, yeah.
Oh, okay.
Yeah, it's okay. Cause you gotta make it a -2, so the bigger one would have to be negative. Okay, so on the bottom, we gotta multiply to make -6, but add to make -1. And this is a hint that I always tell people, if we're fixing to ninja something out, it's probably gonna have one of these in it. So if you have no idea, but you know this, I know, but if you have no idea, try and see if it's one of these. So what could multiply to make -6, but add to make -1? It's gonna have a 3 and a 2, right? Which one's gonna be which? The 3 will be negative, because we gotta be negative. And look, we had one of those on top. So now you factored everything. Once everything is factored, get your ninja sword out. What time is it? Ninja time! So that's your answer, just x plus 1 over x plus 2. Oops, I missed the 2 in my circle. Easy sheezy. Alright, I want to do one. Those were all, like that one was a trinomial over a trinomial. Sometimes people get confused when it's monomials. So let's go ahead and we'll do a multiply one with this. I got 8x cubed y over 2xy squared. And then we're going to go ahead and start multiplying times 7x to the 4th y cubed over 4y. Okay, so actually when they're monomials like this, you've got different options on how to do it. You could just multiply straight across the top, straight across the bottom, and then reduce. But we know that I like my numbers smaller, so I always try to reduce ahead of time. So what I would see on this is I'm looking at it at the regular numbers. I got an 8 on top, and I also have an 8 on bottom, don't I? So this 8, 2 times 4 on the bottom is an 8, so I could ninja this 8 out with that 2 and 4. Now, why I told you earlier you couldn't pick stuff apart, but these are monomials. A monomial is the only time you can do that. So I could say shoo, shoo, shoo. So I'm done with that, and the only number I have left on the top is the 7. Okay, so the variables is what usually confuse the most people. Remember, when you multiply, exponents get added, and when you divide, they get subtracted. So you could say, well, this would reduce to an x squared. You could do that, or you could multiply it first and then reduce it. It doesn't matter. So whatever you feel more comfortable with. I would probably say that makes x squared, right? And then x squared times x to the 4th would make an x to the 6th. So far we're looking at 7x to the 6th. And now we're done. I'm not really ninjaing here, but I'm done with all my x's. And I'm done with that 7. I've got it all over here. So the stuff left, let me get a different color highlighter. The stuff left I haven't messed with yet are the y's. Okay? So with those y's, here you got a y to the 4th. Here you got a y to the 3rd. So you're looking at y to the 4th over y to the 3rd, which would just be no, y to the 4th over y to the 3rd.
Yeah.
So just be y to the 1st, and that'd be it. Yeah, and so if it had ended up, if this had been flipped, show you what to do in that case, you would have put 7x to the 6th over y. You'd have put it like that. So wherever the higher power is, that's where it'll stay. Alright, so let's do some of the fun ones now. I got 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Okay, so like I was telling you at the beginning, now we've got that rational times irrational. So your options are distribute 3x to all these, distribute 3x squared to all of these, distribute 3x to all of those, and then try to start dividing, because fraction means divide. We don't like long division with this stuff. So it's gonna be way simpler, and what our plan of attack is gonna be every time is to factor everything that can be factored. And on this problem, you can factor 3 of the 4 pieces. Okay, so on that top left, there's only 2 terms on it. On the 3x one, there's only 2 terms, and they're not perfect squares, both of them, but they both have a 3x in common. So you're going to take a GCF out. So I'm going to put a 3x outside the parentheses and just backwards distributed. So it was a 3x. I took the whole 3x out. That just leaves a 1 in there. And then minus, it was a 3x squared. I took a 3x out, so there's still an x left. Okay, now, we're probably, I don't know if we're going to want to change that in a little bit or not, I don't know. Because we could have taken a negative 3x out, and that would have made that been an x minus 1. But we'll just wait and see if we need to, I'm not sure. Alright, so on the bottom we got a trinomial, so we look for what multiplies to make negative 5, but adds to make positive 4. And 5, yep. Yep. Okay, so over here, we got that one factored. Over here, I'm looking for what multiplies to make negative 20, but adds to make positive 1.
Oh,
5 and a minus 4, very good. And then on the bottom, still got our 3x, it doesn't factor. So now we'll go ahead and get our ninja sort out and ninja anything. And when you're, a lot of times people don't know that they can ninja across this time sign, but you can, as long as it's top and bottom. So I could take this x plus 5 with this x plus 5. I could take this 3x with this 3x. Okay, so I know I'm going to have an x minus 4 left. Now here's what I was talking about a little bit ago. These I can almost ninja, but this is a positive 1 and this is a negative 1. This is a negative x and this is a positive x. So if I took a negative 1 out of that, that would flip those signs, wouldn't it? So then it would be x minus 1, so So on the top, all we have left is a negative 1 and an x minus 4. And on the bottom, we don't have anything left. We ninja'd everything out. So you could circle that and leave that. That's pretty good. If that's not a choice on the ACT, they might go ahead and distribute. So they might say negative x plus 4 means the same thing. So either of those would be good. That negative trick, that doesn't happen often, but it does happen. So if stuff looks fishy like that, just think, I wonder if they're opposites. All right. Let's do a couple more. This is good stuff. X plus 2. Now all I'm trying to show you are all the different scenarios. So this one right here is not the most common one, but it does happen, and the reason it's not the most common one is the way this denominator factors. These are cubes. And when we did factoring, we had a difference of cubes formula. So we'll have to remember that. This one's already factored, so we're not going to do anything with that. So let me just bring that one down. Okay, difference of cubes. The cube root of x cubed is x. The cube root of 27 is 3. So the first parentheses is the cube root minus the cube root. And then the second parentheses, you square, we did a's and b's, I think, when we wrote it in our notes. You square that a, so that'd be x squared. Plus, you multiply your a and your b, so that would be 3x. Plus, you square your 3, so that would be 9. Now, was that just a coincidence? Look at what's on the other side. Most of the time, this stuff's going to work out friendly for you like that. So now that looks like a big ugly trinomial. Who cares? It's the same thing on the other side. So get your ninja sword. All that's left is x plus 2 over x minus 3. We're chicken dinner. All right, let's do a couple division. I got 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. Okay, so a lot of people panic and freak out when we switch to division, but all we're going to do is rewrite it as a multiplication problem and then do it the same. Because dividing by fraction is multiplying by the reciprocal. So I'm just going to drop this side down. I've had some students in the past say keep, change, flip. That's pretty cool. I've never heard that before. You keep this one, change this one to a multiply sign, and then flip this one. So x squared minus 11x, just taking the reciprocal. So now it's going to be exactly the same as what we've been doing before. And so our plan is to factor everything that can be factored. And all of the 7x is the only thing that's prime. The other three we can factor. So on the 2x minus 10, it's got a GCF. So we would say 7x over, take that 2 out, and that would be x minus 5. Okay, then over here on the top right, what multiplies to make 30 but adds to make negative 11? Both be minuses. No.
No.
Remember, use what you got already as a hint.
5 and 7.
No, 6, you got it, sister. That's all right. Okay, now on the bottom right, they both got an x in common, so you're just going to take a GCF of an x out. So it was x squared, you took an x out, leaves you with an x. It was a 6x, you took an x out, leaves you with 6. So you factored everything as far as it can go. Get your ninja sword out, it's ninja time. Now, what about the 7x and the x? Can you ninja those x's? Yes, because they're not part of binomials. So all we've got left on the top is a 7. All we got left on the bottom is a 2. 7 over 2. All that turned into 7 halves. Isn't that crazy? Isn't that crazy? All right, one more, and I'll quit torturing you. Oops, wrong button. Okay, I got 6x squared. Oh, that's going to be a tough one. 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. Okay, so it's division. So the first thing I'm going to do before I panic is make it a multiplication problem. So I'm going to bring this side down like it is. 6x squared plus x minus 15 over 4x squared. I kept that. I'm going to change it to a multiplication. And I'm going to flip this. Well, it's not a fraction written, which means it's over and understood 1, right? So I'll have a 1 on top. And then a 3x squared plus 5x. Okay, so the 1 can't factor and the 4x squared can't factor. So in order for me to be able to ninja anything out, these two have got to factor. Well, I know that one's got an x GCF, so I'm going to start on that side because I know that. I'm not real sure about the right side. I mean the left. 1 over x times 3x plus 5. Okay, just took an x out. Still got a 4x squared on the bottom over here. Now, I got a pretty good gut feeling that this has got to have a 3x plus 5 in it. Because if it doesn't, I can't ninja anything out. So I wonder if, let's just give this a whirl and see if we can work backwards. When we did this type of factoring in class, we still did our A times C, but then we had to find whatever that was that added to 1, and we had to do it by grouping. So this is like one of the groups already. So 3x times what would give me 6x squared? 2x, right? Oops, 2x, and it's gotta have a minus sign. What would have to go here that would get that negative 15?
3.
So I just worked backwards and didn't have to do that whole ugly factoring there. So now, we factored everything, so what time is it? Ninja time. So on the top, I've got a 2x minus 3, and on the bottom, I've got a 4x cubed, right? Because I got a 4x squared times an x, so 4x cubed. So can I reduce these x's? So no, because on the top, it's a binomial. Can't pick apart a binomial. So that'd be it. That's probably the hardest kind of them. And you won't have as many of those. Let me see what I've got on tomorrow's assignment real fast before I made it last week and I've forgotten already. Okay, it's this, and it's a puzzle time, so that'll help you while you're practicing it new, so that'll be good. Alright, well, I'm sorry you had to be alone, but thank you.
Good.